This is being recorded today, so whenever we get done with the stream, I will be uploading, if not the whole video, clips from the video. If not the whole video, back and look at anything you missed. Look at anything you missed. Look at anything you missed. I'll give everybody a few minutes. If anyone wants to show up before I just start doing my own thing. Alright, so I'm going to go ahead and get started. Today, since the other day was not recorded, we're going to do geometry for this week, which is going to be days 17 through 21. And then I'm going to read a short story to you, Ray Bradbury in Mr. Florence's English 2 class, and then we'll review some of the questions over that. That's from his NTI work. Okay? Okay? We're not gonna need a scientific calculator for anything that we're doing today. No, we will, because we're gonna be doing sine, cosine, and tangent. So what I'm gonna do is I'm gonna pull up this download, this Calculate 84 at Desmos.com. No, there's two different ones. So let's try these and see what they look like. Desmos.com. Okay, so we need scientific calculator. That's pretty cool. Okay, so there's one of the options in this course gives you. She says you go to Desmos.com, use one there, or you can go and download Calculate 84. Calculate 84. Calculate 84. 84 on the App Store. Okay, so this is an app for your phone. App Store. Okay, so this is an app for your phone. App Store. Okay, so it looks just like a regular scientific calculator. So that'll be really helpful. So there's two. If you're doing everything on your phone, or if you're doing stuff online, if you're doing it online, you can go to desmos.com/scientific. It's going to bring up a scientific calculator. If you want to use your phone, you can turn it into a scientific calculator and download the Calculator 84 app. It looks like this is the App Store. I don't know if it is on Android devices. Kind of doesn't look like it, but it might be. So you can try that out and make sure. Alright, so we're getting more NTI for the rest of the year. Okay. So we all got an email this morning, and based on what the governor said, it's pretty likely that we're going to be doing NTI for the rest of the school year. So this is, I said this on Monday, but in case you weren't here and I didn't record it, everything that you're doing now is not just to get you until we come back to regular school. This is what regular school looks like right now. So everything that you're doing right now is going to be, if you're a senior, it's what helps you graduate. If you're a freshman, sophomore, junior, it's what helps you get to the next grade. Is that what you were asking? Deadly Man 102. Deadly Man 102. Deadly Man 102. Deadly Man 102. Or are you asking if you're going to be receiving, like if you need paper copies? Is that what you're asking? Like if you need paper copies? Is that what you're asking? Like if you need paper copies? Is that what you're asking? Like if you need paper copies? Is that what you're asking? Like if you need paper copies? Is that what you're asking? Like if you need paper copies? The suspense is killing me. 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 It's Tyler and it's Tyler and it's Tyler and it's Tyler and Tyler and yes. The new NTI that you're going to get is the exact same as you going to school for the next year. So we have a certain number, it's like 1,086 or 1,800 and something hours that we have to teach kids every year. That's like the contract that the schools have. All this NTI stuff counts toward that. So they're treating every NTI day like a regular school day. So if you don't do your NTI work, two things happen. One, you don't get the grades for them, which would probably make you fail for the school year because it's going to be so much NTI. It's essentially you would fail the last 9 weeks of school year. If your grade's high enough, you might be able to do that and still graduate. But the other thing that's going to happen will prevent that. Because you don't come to school every day, not doing your NTI work is also counted as you being absent. So if you were absent for an entire 9 weeks, you wouldn't be able to graduate. There would be more problems than that. Is that clear? Is that clear? Awesome. Any classes? You want to look at? I think I've got access to most of them. I think I've got access to most of them. I think I've got access to most of them. I think I've got access to most of them. I think I've got access to most of them. I think I've got access to most of them. I think I've got access to most of them. No problem, brother. All right. No problem, brother. Hey, have any more questions? Just type it in here. I'm gonna go ahead and go over. I'm gonna go ahead and go geometry days 17 through 20. Geometry days. So let's go. We're gonna do notes for day 17 through 21. And as I'm going over this, it's going to be examples of what each day's stuff is going to look like, and there shouldn't be anything that's not covered once we get done with this. All right. So for day 17, you're going to be finding missing side lengths for special right triangles. There's two kinds of special right triangles that we're going to be looking at. Those are 45, 45, 90 right triangles and 30, 60, 90 right triangles. The reason they're called special right triangles is because they have special properties that only apply to them, that make it a little bit easier to find missing sides without using Pythagorean theorem or anything like that. So, what are the special properties? For a 45, 45, 90 special right triangle, the 45 and 45 angles are across from the legs of the triangle, okay? And the 90-degree angle is across from the hypotenuse, and we know that we already know that that's true because any triangle, any right triangle, the hypotenuse is going to be across from the 90-degree angle. Okay, so if we know that that's a leg, that's and that's the hypotenuse. If this is 45 and this is 45, we know that these two sides, or these two legs, are going to be the same length. So like in this example, here, this is opposite, this side that's 7 is opposite of this 45-degree angle. So we know that the side opposite of the other 45-degree angle is also going to be 7. Okay? Now, the other property for a 45, 45, 90 is the hypotenuse is going to be whatever one of these legs are. So in this case, it's 7. And that's going to be multiplied by the square root of 2. Okay? So if this is 7 right now, so our equation would be y equals 7, because we know that those are going to be the same. X equals 7 times the square root of 2. Okay? So if this was 10, y would be 10, and x would be 10 square root of 2. Okay? So as far as I know for day 17, you don't have to simplify it any farther than this. I think this is where she's wanting you to simplify it to. So 7 times square root of 2, that's going to be 7 square root of 2. Okay? Moving on to... Okay, before we do 30, 60, 90, we're going to do an example where it gives us one angle, and instead of giving us the legs, it gives us the opposite that it did last time. Last time it gave us one leg and not the hypotenuse. This time it's going to give us the hypotenuse, and we should be able to figure out what the two legs are based on that. If we know that our rule is the hypotenuse is one leg multiplied by radical 2, then all we got to do is look at this number that comes before the radical, and that'll tell us what the length of the two sides are. Okay? So this side is going to be one leg times radical 2, so we know that each of these legs is going to be 4. And she's worked it out. Said since the hypotenuse is 4 radical 2, this means the legs are both 4. Therefore, x equals 4 and y equals 4. Okay? So those are 45, 45, 90 triangles. Now, moving on to 30, 60, 90 triangles. Now it's a little bit more involved, but it's still not difficult to do. You just got to remember a couple simple rules and you'll be able to do it. So on a 30, 60, 90, we know that all triangles have to add up to 180 degrees interior angles. Right? So 30, 60, 90 takes care of that rule. In a 30, 60, 90 triangle, these are the angles, 30, 60, 90. What she has written in under the angles are what the opposite side looks like. Okay? So when we're worrying about our rules, So we want to know what the side opposite of the 30-degree angle is. So in this case, here's the 30-degree angle, and it's 7. We want to know what the side opposite of the 60-degree angle is. It'll be y in this one. And we want to know what the side opposite of the 90-degree angle is, which would be x. Okay? The reason we have to know that, the reason we have to know the opposite of the 30 is the short leg, the opposite of 60 is the long leg, and the opposite of 90 is hypotenuse, is because they all have different hypotenuse. Okay? The way that you find these sides, your short leg is going to be your short leg, so it's going to be whatever it is. Like in this case, this is our 30-degree angle. Opposite of our 30-degree angle is going to be 7. It's just what it is. It's just going to be 7 because that's what it tells us that it is. Our long leg is going to be z times radical 3. So in this case, we're going to do, our z is 7, so this side's going to be 7 radical 3, kind of like we did up here with 7 radical 2. We just plugged that in. So our long leg is going to be our short leg radical 3. Our hypotenuse is going to be 2 times our short leg. So what we really need to know is our short leg to figure out these other two things. And then if we know one of the other things, we can reverse engineer it and figure out what our short leg is. So, for example, she's done this one for you. So y is across from 60 degrees. So it is going to be y equals 7 radical 3. So that is because our long leg is going to be our short leg radical 3, so that's 7 radical 3. X is the hypotenuse. Our hypotenuse says we're going to multiply 2 by the short leg. So x equals 2 times 7, which is our short leg, which gives us 14. Okay? So that's a 30, 60, 90, knowing the short leg. Number 4, we don't know the short leg. We know the hypotenuse. We know where the 60, 90, 30-degree angles are. Okay? So the first thing that we're going to do is we know that the hypotenuse is 2 times the short leg. So if we divide our hypotenuse by 2, it'll give us our short leg. So since the hypotenuse is 8, so y equals 4, because we're dividing 8 by 2, that gives us 4. Now that we know our short leg, we can multiply that by square root of 3. So that means x equals 4 times the square root of 3. Okay. If that was a little bit fast, I am recording this and I'm going to post it so you can go back and look at that afterwards. Okay, so those are 30, 60, 90 triangles. Alright, now trigonometric ratios. Those sound a lot more complicated than they are. It's actually really, really simple if you don't psych yourself out about it and convince yourself that it's hard to do. Because a lot of it's going to be done with your calculator. In this part, it's just going to be putting numbers over numbers and plugging stuff in. And the next thing, I think it's day 19, it's just going to be putting stuff in your calculator. Okay? So we are going to learn sine, cosine, and tangent. Okay? And what you need to know in order to do all of these is what adjacent, hypotenuse, and opposite mean. Okay? And what those mean are whatever angle you're trying to figure out. You need to know what the opposite side is. So this is the opposite side from angle A. You need to know what the adjacent side is. So it's the side that's next to the angle that is not the hypotenuse. So here's our adjacent side of angle A. And our hypotenuse, which we already know, is opposite our 90-degree angle here. Okay, so as long as you know opposite side, adjacent side, hypotenuse side, you'll be able to do trigonometric ratios. Because sine is the opposite side over the hypotenuse side. Okay, so if we were finding the sine of angle A, we would go opposite side divided by the hypotenuse. Whatever those two. If this side was 5 and this side was 4, we would say 5 over 4. That's the sine of A. Okay. If we're doing cosine, we want the adjacent over the hypotenuse. So we would do this number over this number. Tangent, opposite, over adjacent. So they're all different things. And the way that it was taught to me back in the day, when I was in middle school and high school, I had a teacher that would dress up in a headdress and call herself Chief Sokotoa, just because she thought it sounded like a Native American name. And that is because this is how you can remember what sine, cosine, and tangent are. Sine is opposite O over hypotenuse, so S-O-H. Cosine is H. The C over adjacent over hypotenuse, so A-H-C-A-H. Tangent is opposite over adjacent, so that's T-O-A. So-ka-to-o. Do you remember that? It's pretty easy. If you can remember the words opposite, adjacent, hypotenuse, then all you need to write on your paper whenever you're doing this is Sokotoa. That makes it really easy to remember. So, knowing that stuff, we're going to look at this example right here where she's done the sine, cosine, and tangent of this one triangle. Okay? So, looking for the cosine is what the actual problem wants us to do. That's going to be the first one. We're going to do the cosine of Z. Let's look at cosine. Cosine wants adjacent over hypotenuse. Okay? So, where is angle Z? Here's angle Z. So where is our adjacent angle? Here's our adjacent angle because it's next to, it connects to angle Z, but it's not the hypotenuse. Okay, so there's adjacent. And now we need hypotenuse across from right angle. So all we're going to do is 24 over 26. Cosine of Z equals 24 over 26. Let's see if that's what she did. Yep. Cosine of Z equals 24 over 26. And then all she did was simplify that to 12 over 13. Something important that you're going to need to do. I don't remember if you need to do it at this point, but you need to make sure that your calculator, once we get a little bit farther down, when you go into mode, you need to make sure that your calculator is set to degrees instead of radians, because it will give you different answers once we start finding inverse cosine, sine, tangent, inverse trigonometric ratios. Okay, then she went through and she did sine and tangent. So sine is opposite over hypotenuse, so the opposite of Z is 10 over hypotenuse, is 26, so 10 over 26 simplifies to 5 over 13. Sine of Z equals 5 over 13. And the tangent, opposite over adjacent. Opposite over adjacent. 10 over 24 simplifies to 5 over 12. Okay, so all we're doing is looking at this, taking what information is given to us. We're trying to find something of angle Z. It gives us all three sides, and we're just plugging numbers in. Okay. Now on this one, let's see. All of these are the same because they give us all of these are the same because they give us all of the sides are given to us. All of the sides are given to us. Here's where you need to make sure that your calculator's in degrees. Okay. Because on this one, she doesn't want you to just leave it as a fraction. She wants you to find it to the nearest 10,000. So all you're going to do is put it in your calculator, and instead of that fraction, you're actually going to do 5 divided by 13. That's going to give you 0.3846. Okay, and that's the 10,000th. So that is 1, 2, 4. So that is tens, hundreds, thousands, 10,000s. 4 decimal places. Okay. And she did an example right here on day 19 where you're finding the missing side. Okay, now we're moving to something a little bit different. We're using what we used up here with our sine, cosine, and tangent, and now we're applying some algebra to it using basic algebra. So, if you're missing a side, we can use what we know about sine, cosine, and tangent to find that side. Okay, so it gives us this 30-degree angle. We know that the sine of an angle puts opposite over hypotenuse. So we can do sine of 30 degrees equals opposite over hypotenuse, which would be x over 12. So that's this right here minus the parentheses. And then all we do is do basic algebra. So sine of 30 degrees equals x over 12. We multiply both sides by 12, eliminating that number right there. And then we get x equals 12 sine 30. And that is exactly what you type in your calculator. 12 sine 30. There are buttons on your calculator that say sine, cosine, tangent. That's it, okay? And then above those buttons, if you hit second in blue, I think most of the second functions on these calculators are, you'll see sine, cosine, tangent, but it'll have a little negative 1 exponent. That's the inverse of that thing, and that's what we're going to be doing later on in this NTI. Okay? So, doing another one where we're missing a side. We need to figure out what side we're missing, because we need to do a trigonometric function that finds that side, or that includes that side. In this case, it gave us 22 degrees. So what do we need? We have our hypotenuse, we have 11, and we need to know our adjacent. So we need to figure out which trigonometric function uses adjacent and hypotenuse. Okay? AH. Trying to remember which one uses AH. See one right there. CAH. So we're going to use cosine. Okay, so the cosine of our angle, 22, equals adjacent over hypotenuse, x over 11. So we put cosine 22 equals x over 11, and then do basic algebra. Get rid of that 11, multiply both sides by 11, x equals 11, cosine 22, x equals 10.2. Just plugging stuff in. If it's given us 26 on number 11, we need opposite, we know hypotenuse. Opposite hypotenuse, that is sine, S-O-H, sine opposite over hypotenuse. So we're going to do sine of 26 equals opposite x over hypotenuse, 18. Sine 26 equals x over 18. Multiply both sides by 18 to get rid of it. X equals 18 sine 26 degrees. Put that in your calculator, it gives you 17 or 7.9. Okay? Pretty simple. You're just plugging stuff in. Use the information that you're given. You can't solve stuff with information that you don't have. So if it gives you a hypotenuse, and the x or the unknown variable is adjacent, then you need to figure out which trigonometric function uses adjacent and hypotenuse. If it gives you opposite and adjacent, you need to figure out which one uses opposite and adjacent. Just whatever information is given to you, that's what you use. Okay. And now let's see. Yeah, we're gonna do 12 because this is a little bit different. Just because instead of the x being the top number in your fraction, the x is going to be the bottom number in your fraction. So you're going to have to do an extra step. So we have our angle, and it's given us opposite and adjacent. Okay, so that's going to be tangent, TOA, T-O, tangent. Okay, so we're going to say tangent of 39 degrees, just like we have been doing, equals opposite over adjacent. What's different is our opposite is 12, so that's going to be our top number. Opposite over adjacent is x. So that gives us 12 over x, where everything that we've been doing before is x over x over. So we're going to multiply both sides by x, just like we would normally do. And that'll give us x times tangent 39 degrees equals 12. Now we're going to divide both sides, because this is being multiplied. We're going to divide both sides by the tangent of 39, and that will give us x equals 12 divided by tan 39 degrees. So that's what you type in your calculator. 12 divided by tan 39, and that'll give you x equals 14.8. Okay, now for this day 20, for the last stuff, this is where it's important that you need to know how to find the inverse of sine, cosine, and tangent. So when we're doing this stuff,
all you're going to be doing is typing in your calculator. All you're going to be plugging stuff in, typing in your calculator. Plugging stuff in, typing in your calculator.
See this -1 right here? -1. All these are going to be cosine. That is the inverse operation that I was talking about. So on your calculator, let's see if we can find this. See if we can find this. Desmos scientific calculator. All right. So on your calculator, this is what sine, cosine, and tangent look like. This is what the inverse of those things look like, and that's what we're going to be using on each of these. Okay? So, we're still using opposite adjacent hypotenuse. So if this is the angle that it's given us, instead of finding the sides this time, we're finding the angles. Okay? So we don't know this angle, but we know adjacent angle, and we know adjacent, and we know hypotenuse. So adjacent and hypotenuse is going to be cosine. So that's what we need for that. So we're going to do the inverse of cosine. So we're going to hit the cosine with the -1, which on your calculator you'll have to hit second, and then cosine. Or if you're using the Desmos calculator, you'll just be able to click inverse cosine. And then we're just plugging in adjacent over hypotenuse. And that's what you type in your calculator. Second cosine 41/42. Hit enter. It'll give you 13 degrees. When you write your answers down, if you're doing this on paper, if you're doing it online, it should be multiple choice. But if you're doing this on paper, remember to write your degrees. Whenever we were doing the sides, since it didn't give us units of measurement, it didn't really matter. But whenever you're working finding angles, you have to do it in degrees. So make sure you write that down. Moving on to number 14, it gives us hypotenuse, adjacent. Cosine is adjacent over hypotenuse. Second cosine 44/47 equals 21. Pretty simple. On this one, don't know the angle, but it gives us adjacent hypotenuse. Second cosine 29/50, 55 degrees. Okay. So all the trigonometric functions sound really different. Some of them may have words that you haven't seen before, that seem unfamiliar, but I promise that it's just as easy as anything else that we've done in class this year. So that is your notes for this week's NTI for geometry. Like I said, I'll be uploading, if not the entire video, I'll be uploading clips of the video that have, like I'll title it Day 17, and that'll be the clip of me going over Day 17 or Day 20. So you'll be able to see exactly what you need to know for that specific day. Okay? So we are done with that. Okay? I am going to go ahead and go to English. And we are gonna look at day. Let's look at this. Let's just post it. An occurrence at Owl Creek Bridge. Okay, so use the above text. Use the text of the above story to answer the following questions in a doc and turn it in discussion questions. Please answer these questions with a full paragraph response and turn in your responses in a doc. Okay, Ambrose Bierce was one of the only major authors to see combat during the Civil War. He served in the 9th Regiment Indiana Volunteers. Alright, so let's read the story. Alright, this will probably be the last thing that I stream today. But we'll read the story, and then we will look at some of the questions and maybe talk about it. Okay. So this is an occurrence at Owl Creek Bridge by Ambrose Bierce. Set during the American Civil War, an occurrence at Owl Creek is Bierce's most famous short story. It was first published in the San Francisco Examiner in 1890. It then appeared in Bierce's 1891 collection, Tales of Soldiers and Civilians. We encourage students and teachers to use our Occurrence at Owl Creek Bridge study guide to learn more about the study.
learn more about the study guide. To learn more about the study guide.
Ooh. Plot summary, character analysis, genre, themes, quotes, seems like, quotes, seems like. All right, so this is where the discussion questions come from. That are part of your NTI. So might be a good idea to look at this study guide. Might be a good idea to look at this. All that is it's up here. It's this link that's in this top little intro. So I'm gonna go ahead and read the story. A man stood upon a railroad bridge in northern Alabama, looking into the swift water 20 feet below. The man's hands were behind his back, the wrists bound with a cord. A rope closely encircled his neck. It was attached to a stout cross timber above his head, and the slack fell to the level of his knees. Some loose boards laid upon the sleepers supporting the metals of the railway supplied a footing for him and his executioners, 2 private soldiers of the Federal Army, directed by a sergeant who in civil life may have been a deputy sheriff. At a short remove upon the same temporary platform was an officer in the uniform of his rank, armed. He was a captain. A sentinel at each end of the bridge stood with his rifle in a position known as support, that is to say, vertical in the front of the left shoulder, hammer resting on the forearm thrown straight across the chest. A formal and unnatural position, enforcing an erect carriage of the body. It did not appear to be the duty of these 2 men to know what was occurring at the center of the bridge. They merely blockaded the 2 ends of the foot planking that traversed it. Beyond one of the sentinels, nobody was in sight. The railroad ran straight away into a forest for 100 yards, then curving was lost to view. Doubtless there was an outpost farther along. The other bank of the stream was open ground, a gentle acclivity topped with a stockade of vertical tree trunks, a loophole for rifles, with a single embrasure of which protruded the muzzle of a brass cannon commanding the bridge. Midway of the slope between the bridge and fort were the spectators. A single company of infantry in line at parade rest, the butts of the rifles on the ground, the barrels inclining slightly backwards against the right shoulder, hands crossed upon the stock. A lieutenant stood at the right of the line, the point of his sword upon the ground, his left hand resting upon his right. Excepting the group of 4 at the center of the bridge, not a man moved. The company faced the bridge, staring stonily, motionless. The sentinels facing the banks of the stream might have been statues to adorn the bridge. The captain stood with folded arms, silent and observing the work of his subordinates, but making no sign. Death is dignitary to who, when he comes announced, is to be received with formal manifestations of respect, even by those most familiar with him. In the code of military etiquette, silence and fixity are forms of deference. The man who was engaged in being hanged was apparently about 35 years of age. He was a civilian, if one might judge from his habit, which was that of a planter. His features were good, straight nose, firm mouth, broad forehead, from which his long, dark hair was combed straight back, falling behind his ears to the collar of his well-fitting frock coat. He wore a mustache and pointed beard, but no whiskers. His eyes were large and dark gray, and had a kindly expression which one would hardly have expected in one whose neck was in the hemp. Evidently, this was no vulgar assassin. The liberal military code makes provision for hanging many kinds of persons, and gentlemen are not excluded. The preparations being complete, the 2 private soldiers stepped aside and each drew away the plank upon which he had been standing. The sergeant turned to the captain, saluted, and placed himself immediately behind that officer, who in turn moved apart with 1 pace. These movements left the condemned man and the sergeant standing on 2 ends of the same plank, which spanned 3 of the cross ties of the bridge. The end upon which the civilian stood almost but not quite reached a 4th. This plank had been held in place by the weight of the captain. It was now held by that of the sergeant. At a signal from the former, the latter would step aside, a signal tilt, and the condemned man would go down between the 2 ties. The arrangement commended itself to his judgment as simple and effective. His face had not been covered, nor his eyes bandaged. He looked a moment at his unsteadfast footing, then let his gaze wander into the swirling water of the stream racing madly beneath his feet. A piece of dancing driftwood caused attention, and his eyes followed it down the current. How slowly it appeared to move, what a sluggish stream. He closed his eyes, and
order to fix his last thoughts upon his wife and children. The water touched to gold by the early sun, the brooding mists under the banks at some distance down the stream, the fort, the soldiers, the piece of drift, all had distracted him, and now he became conscious of a new disturbance. Striking through the thought of his dear ones was a sound which he could neither ignore nor understand, sharp, distinct, metallic percussion, like the stroke of a blacksmith's hammer upon the anvil. It had the same ringing quality. He wondered what it was and whether immeasurably distant or nearby it seemed both. Its recurrence was regular, but as slow as the tolling of a death knell. He awaited each stroke with impatience, and he knew not why, apprehension. The intervals of silence grew progressively longer, and days became maddening. With their greater in frequency, the sounds increased in strength and sharpness. They hurt his ear like the thrust of a knife. He feared he would shriek. What he heard was the ticking of his watch. He unclosed his eyes and saw again the water below him. If I could free my hands, he thought, I might throw off the noose and spring into the stream. By diving, I could evade the bullets, and swimming vigorously, reach the bank, take to the woods, and get away home. My home, thank God, is as yet outside their lines. My wife and little ones are still beyond the invaders' farthest advance. These thoughts, which have here to be set down in words, were flashed into the doomed man's brain. Rather than evolved from it, the captain nodded to the sergeant, and the sergeant stepped aside. Peyton Farquhar was a well-to-do planter of an old and highly respected Alabama family. Being a slave owner, and like other slave owners, a politician, he was naturally an original secessionist and ardently devoted to the Southern cause. Circumstances of an imperious nature, which it is unnecessary to relate here, had prevented him from taking service with the gallant army that had fought the disastrous campaigns ending with the fall of Corinth. He had chafed under the inglorious restraint, longing for the release of his energies, the larger life of the soldier, the opportunity for distinction. That opportunity, he felt, would come, as it comes to all in wartime. Meanwhile, he did what he could. No service was too humble for him to perform in aid of the South. No adventure too perilous for him to undertake if consistent with the character of a civilian who was at heart a soldier, and who in good faith and without too much qualification assented to at least a part of the frankly villainous dictum that all is fair in love and war. One evening, while Farquhar and his wife were sitting on a rustic bench near the entrance to his grounds, a gray-clad soldier rode up to the gate and asked for a drink of water. Miss Farquhar was only too happy to serve him with her own white hands. While she was fetching the water, her husband approached the dusty horseman and inquired eagerly for news from the front. The Yanks are repairing the railroad, said the man, and are getting ready for another advance. They have reached the Owl Creek Bridge. Put it in order and built a stockade on the north bank. The commandant has issued an order. The commandant has issued an order, which is posted everywhere, declaring that any civilian caught interfering with the railroad, its bridges, tunnels, or trains will be summarily hanged. I saw the order. How far is it to the Owl Creek Bridge? Farquhar asked. About 30 miles. Is there no force on this side of the creek? Only a picket post half a mile out on the railroad and a single sentinel on this end of the bridge. Suppose a man, a civilian and student of hanging, should elude the picket post and perhaps get the better of the sentinel, said Farquhar, smiling. What would he accomplish? The soldier reflected. I was there a month ago, he replied. I observed that the flood of last winter had lodged a great quantity of driftwood against the wooden pier at this end of the bridge. It is now dry and burned like talc. The lady had now brought the water, which the soldier drank. He thanked her ceremoniously, bowed to her husband, and rode away. An hour later, after nightfall, he repassed the plantation, going northward in the direction from which he had came. He was a Federalist scout. As Peyton Farquhar fell straight downward through the bridge, he lost consciousness and was one already dead. From this state he was awakened, ages later it seemed to him, by the pain of a sharp pressure upon his throat, followed by a sense of suffocation. Keen, poignant agonies seemed to shoot from his neck downward through every fiber of his body and limbs. These pains appeared to flash along well-defined lines of ramification and to beat with an inconceivably rapid periodicity. They seemed like streams of pulsating fire heating him to an intolerable temperature. As to his head, he was conscious of nothing but a feeling of fullness, congestion. These sensations were unaccompanied by thought. The intellectual part of his nature was already effaced. He had power only to feel, and feeling was torn. He was conscious of motion, encompassed by a luminous cloud, of which he was now merely a fiery heart without material substance. He swung through unthinkable arcs of oscillation, like a vast pendulum. Then all at once, with terrible suddenness, a light about him shot upward with the noise of a light splash. A frightening roaring was in his ears, and all was cold and dark. The power of thought was restored. He knew that the rope had broken, and he had fallen into the stream. There was no additional strangulation. The noose of his neck was already suffocating him and kept the water from his lungs. To dive hanging at the bottom of a river, the idea seemed to him ludicrous. He opened his eyes in the darkness and saw above him a gleam of light, but how distant, how inacceptable. He was still sinking, for the light became fainter and fainter until it was a mere glimmer. Then it began to grow and brighten, and he knew that he was rising toward the surface. Knew it reluctance, for it was now very comfortable. To be hanged and drowned, he thought, that is not so bad, but I do not wish to be shot. No, I will not be shot. That is not fair. I will not be shot. He was not conscious of an effort, but a sharp pain in his wrist apprised him that he was trying to free his hand. He gave the struggle his attention. As an idler might observe the feat of a juggler without interest in mirth. What splendid effort! What magnificent, what superhuman strength! Ah, that was a fine endeavor. Bravo! The cord fell away. His arms parted and floated upward. The hands dimly lit each side the growing light. He watched them with new interest as first one and the other pounced upon the noose at his neck. They tore it away and thrust it fiercely aside, its undulations resembling those of a water snake. Put it back, he thought. He shouted these words to his hands, for the undoing of the noose had been succeeded by the direst pain that he had yet experienced. His neck ached horribly. His brain was on fire. His heart, which had been fluttering faintly, gave a great leap, trying to force itself out his mouth. His whole body was racked and wrenched with an unsupportable anguish, but his disobedient hands gave no heed to the command. They beat the water vigorously with quick, downward strokes, forcing him to the surface. He felt his head emerge. His eyes were blinded by the sunlight. His chest expanded convulsively, and with a supreme and crowning agony, his lungs engulfed a great draught of air, which instantly expelled in a shriek. He was now in full possession of his physical senses. They were indeed preternaturally keen and alert. Something in the awful disturbance of this organic system had so exalted and refined them that they made record of things never before perceived. He felt the ripples upon his face and heard their separate sounds as they struck. He looked at the forest on the bank of the stream, saw the individual trees, the leaves, the veining of each leaf, saw the very insects upon them, the locusts, the brilliant-bodied flies, the gray spiders stretching their webs from twig to twig. He noticed the prismatic colors in all the dewdrops and a million blades of grass, the humming of the gnats that danced above the eddies of the stream, the beating of the dragonfly's wings, the strokes of the water spider's legs, like oars which had lifted their boat. All these made audible music. A fish slid along beneath his eyes, and he heard the rush of his body parting the water. He had come to the surface facing down the stream. In a moment, the visible world seemed to wheel slowly around himself, the pivotal point, and he saw the bridge, the fort, the soldiers upon the bridge, the captain, the sergeant, the two privates, his executioners. They were in silhouette against a blue sky. They shouted and gesticulated, pointing at him. The captain had drawn his pistol but did not fire. The others were unarmed. Their movements were grotesque and horrible, their forms gigantic. Suddenly he heard a sharp report, and something struck the water smartly within a few inches of his head, spattering his face with spray. He heard a second report, and saw one of the sentinels with his rifle at his shoulder, a light cloud of blue smoke rising from the muzzle. The man in the water saw the eye of the man on the bridge gazing into his own through the sights of the rifle. He observed that it was a gray eye, and remembered having read that gray eyes were keenest, and that all famous marksmen had them. Nevertheless, this one is missed. A counter swirl had caught Farquhar and turned him half around. He was again looking into the forest on the bank opposite the fort. The sound of a clear, high voice and a monotonous sing-song now rang out behind him and came across the water with a distinctness that pierced and subdued all other sounds, even the beating of the ripples in his ears. Although no soldier, he had frequented camps enough to know the dread significance of that deliberate, drawling, aspirated chant. The lieutenant on shore was taking a part in the morning's work. How coldly and pitilessly, with what an even, calm intonation, presaging and enforcing tranquility in the men, with what accurately measured intervals fell those cruel words: "Attention, company! Shoulder arms! Attention, company! Shoulder fire! Attention, company!" Farquhar dived as deeply as he could. The water roared in his ears like the voice of Niagara, yet he heard the dulled thunder of the volley, and rising again toward the surface, met shining bits of metal, singularly flattened, oscillating slowly downward. Some of them touched him on the face and hands and fell away, continuing their descent. One lodged between his collar and neck. It was uncomfortably warm, and he snatched it out. As he rose to the surface, gasping for breath, he saw that he had been a long time underwater. He was perceptibly farther downstream, nearer to safety. Soldiers had almost finished reloading. The metal ramrods flashed all at once in the sunshine as they were drawn from the barrels, turned in the air, and thrust into their sockets. The two sentinels fired again, independently and ineffectually. The hunted man saw all over his shoulder. He was now swimming vigorously with the current. His brain was as energetic as his arms and legs, and his thought was rapidity of lightning. The officer, he reasoned, will not make the martinet's error a second time. It is as easy to dodge a volley as a single shot. He has probably already given the command to fire at will. God help me, I cannot dodge them all. An appalling splash within 2 yards of him was followed by a loud rushing sound, diminuendo, which seemed to travel back through the air to the fort and died in an explosion which stirred the fairy river to its deeps. A rising sheet of water curved over him, fell down upon him, binded him, and strangled him. The cannon had taken a hand in the game. As he shook his head free from the commotion of the smitten water, he heard the deflected shot humming through the air ahead, and in an instant it was cracking and smashing the branches of the forest beyond. They will not do that again, he thought. The next time they will use a charge of grape. I must keep an eye upon the gun. Smoke will apprise me. The report arrives too late and lags behind the missile. That is a good gun. Suddenly he felt himself whirled round and round, spinning like top. The water, the banks, the forest, a now distant bridge, fort and men were all commingled and blurred. Objects were represented by their colors only, circular, horizontal streaks of color. That was all he saw. He'd been caught in a vortex and was being whirled on with a velocity of advance and gyration that made him giddy and sick. In a few moments he was flung upon the gravel at the foot of a left bank of the stream, the southern bank, and behind a projecting point which concealed him from his enemies. The sudden arrest of his motion, the abrasion of one of his hands on the gravel, restored him, and he wept with delight. He dug his fingers into the sand, threw it over himself, and handfuls audibly blessed it. It looked like diamonds, rubies, emerald. He could think of nothing beautiful which it did not resemble. The trees upon the banks were giant garden plants. He noted a definite order in their arrangement, inhaled the fragrance of their blooms. A strange, roseate light shone through the spaces among their trunks, and wind made in their branches the music of Boolean harps. He had no wish to perfect his escape, was content to remain in that enchanting spot until retaken. A whiz and rattle of grape shot among the branches high above his head roused him from his dream. The baffled cannoneer had fired him a random farewell. He sprang to his feet and rushed up the sloping bank and plunged into the forest. All that day he traveled, laying his course by the rounding sun. The forest seemed interminable. Nowhere did he discover a break in it, not even a woodman's road. He had not known that he lived in so wild a region. There was something uncanny in the revelation. By nightfall he was fatigued, footsore, and famishing. The thought of his wife and children urged him on. At last he had found a road which led him in what he knew to be the right direction. It was as wide and straight as a city street, yet it seemed untraveled. No fields bordered it, no dwelling anywhere. Not so much as the barking of a dog suggested human habitation. The black bodies of the trees formed a straight wall on both sides, terminating a horizon in a point, like a diagram in a lesson of perspective. Overhead, as he looked up through the rift in the wood, shone great garden stars, looking unfamiliar and grouped in strange constellations. He was sure that they were arranged in some order which had a secret and malign significance. The wood on either side was full of singular noises, among which once, twice, and again distinctly heard whispers in an unknown tongue. His neck was in pain, and lifting his hand to it, found it horribly swollen. He knew that it had a circle of black where the rope had bruised it. His eyes felt congested. He could no longer close them. His tongue was swollen with thirst. He relieved its fever by thrusting it forward from between his teeth into the cold air. How softly the turf had carpeted the untraveled avenue. He could no longer feel the roadway beneath his feet. Doubtless, despite his suffering, he had fallen asleep while waking. For now, he sees another scene. Perhaps he was merely recovered from a delirium. He stands at the gate of his own home. All is as he left it, and all bright and beautiful in the morning sunshine. He must have traveled the entire night. As he pushes open the gate and passes up the wide white wall, he sees a flutter of female garments. His wife, looking fresh and cool and sweet, steps down from the veranda to meet him. At the bottom of the steps, she stands waiting, with a smile of ineffable joy, an attitude of matchless grace and dignity. Ah, how beautiful she is! He springs forward with extended arms. As he is about to clasp her, he feels a stunning blow upon the back of his neck. A blinding white light blazes all about him with a sound like the shock of a cannon. Then all is darkness and silence. Peyton Farquhar was dead. His body, with a broken neck, swung gently from side to side beneath the timbers of the Owl Creek Bridge.
Alright. So there is the story. And for that, your discussion questions are: Ambrose Bierce is one of the only major authors, to see combat during the Civil War with the 9th Regiment of Indiana Volunteers. What evidence can you provide that he knows what he's talking about in the telling of his story? Do you detect any bias of his writing? Does he favor the Union over the Confederates, or is he seemingly impartial? So, how can you tell he knew what he was talking about? And the fact that he's from the North, can you tell it in his writing? Does he seem to favor the North more, or make the South sound like they don't know what they're doing, or that they were in the wrong? Number 2, do we know whether Farquhar actually burned the bridge? Though we are told the Union scout planted the idea in Farquhar's mind to burn the bridge, and he must have reported Farquhar's betrayal, which resulted in his sentence to be hanged. How do we know he actually committed the crime and deserved to be hanged? So, try to find evidence in the story that he actually burned the bridge. Number 3, please describe the situation Peyton Farquhar faces and how the plot unfolds. So what is actually happening to him in this story? Why is he at the bridge? Why are there so many people there? What are they getting ready to do to him? What happens to him? What's running underneath him? All that stuff. And finally, in this story, the Civil War serves as a backdrop. Bierce's main intent is to examine the psychology of someone in a life-to-death situation. What does the story imply about human psychology in the face of death? In other words, what does the story say about people who are in a near-death scenario? So this guy is about to die. What does this story and how he responds to being ready to die? What does that have to do with how you think people respond in situations where they're about to die? Do you think he responded normally? Do you think the way that he responded was crazy and weird? How do you think that someone else would respond in a similar situation? So just write how you think people respond and what you think this story says about how people respond in near-death situations. And that is it for our stream today. I will be uploading videos of this stream. If anybody has any questions, you can email them to me. You can post them on the Google Classroom page. You can send private messages through Twitch if you can. More than welcome to do that. Go to the Jarad Bagshaw YouTube page that has its picture of me and my wife is the emblem, and it has videos of geometry and some other stuff on there. You can go there and you can leave comments or do something like that. But everybody have a great day. Stay safe. Stay inside if at all possible. I know everybody needs groceries and there's things that everybody's got to do. Do what you can to make sure that you stay safe and that everybody around you stays safe. Have a great day.